Hello, College Biology. Welcome to Cellular Respiration Part 3. We're going to actually go into respiration this time. We're going to concentrate on phase 1 of respiration, which is glycolysis. Now, the word glycolysis is made of words that we are familiar with. The glyco comes from the root for glucose, so this is about glucose. And then olysis, lysis, like hydrolysis or lysosomes. That has to do with breaking up. So part 1 is breaking up glucose. That is the goal of phase 1, breaking up glucose. And if we look at our big picture with all these complicated cellular respirations, glycolysis rather, is this section that's occurring over here, glycolysis. And you'll note this is our model, this little rudimentary model of a mitochondria, which is trying to tell us that glycolysis does not happen in a mitochondria. Glycolysis happens outside of the mitochondria. So phase 1 of cellular respiration doesn't even involve the mitochondria at all. It occurs in the cytoplasm, outside of the mitochondria, in, the goopy part of the cell. So what are we going to be looking for? That's this section. So let's take a look at that in a different format. In this, we have our glucose monosaccharide in its linear form, and we're going to run through the reactions here. The first step, we have hexokinase. Now, to start this off, we need ATP. So, hexokinase is an enzyme with the help of ATP, which changes glucose into glucose 6-phosphate. You can see they added a phosphate over here. And so then we have another enzyme, phosphoglucomutase, which changes it to fructose 6-phosphate, and then we have phosphofructokinase, which changes it to fructose 1,6-diphosphate, which apparently we then have an enzyme aldolase, which breaks this up into two different particles, glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, which, by the way, dihydroxyacetone phosphate can isomerize itself into glyceraldehyde 3-phosphate. Oh, I'm sorry, that's not isomerization. That's the normal enzymatic activity of triocephosphate isomerase. Oh, it is an isomerizing enzyme. Who knew? So then, tricephosphate dehydrogenase will change all of this. Okay, I'm done. I can't handle this. It's madness. All right, clearly, this level of intricacy is not something I'm going to impose upon you. So don't worry about this. The big idea is that it's not one reaction. It's a lot of reactions. Glucose is being broken down by a lot of reactions to get to this final product down here, pyruvate. That's what we need. And during this process, we can see some things happen. One, ATP to ADP, ATP to ADP. It takes 2 ATP to get this ball rolling, once at the beginning and once in the third step. Then we can also see that we are making ATP back again here and here. But actually, it looks like we get 2 ATP back, but we actually get 4 because we have these two parts. So this guy will go through and get 2 ATP, and then this guy will convert itself into this, and it'll get 2 more ATP. So we actually get we use 2, we make 4, so we get 2 ATP out of this. And we get 2 pyruvate out of this. And we get 2 NADH out of this. And NADH is not something we've talked about, but it is an electron carrier. NADH is what's grabbing the electrons, which we will use later in a later phase of cellular respiration. So we get 2 ATP, 2 pyruvate, and 2 NADH electron carriers, which we're going to use later. So let's summarize glycolysis. Phase 1. Glucose is broken down into pyruvate over at least 10 reactions. It requires 2 ATP to start, but yields 4 ATP for a net of 2 ATP. This occurs in the cytoplasm. This is just floating around in the cell. This is not part of the mitochondria yet. And this gives us pyruvate, NADH, and a little bit of ATP, which we can use. After this comes phase 2, the transition into the mitochondria. I hope this helps. Struggle well.